next presenter is David Lawrence, who will be presenting DNS at the Ietf. In the spirit of acronyms that are being spelled out, David is an SEA, Software Engineering Architect at SALESFORCE, and he has traveled to us today from Northern Vermont. This is David's third time presenting at NANOG. His first talk was for the Ietf status update on encrypted DNS at NANOG 77 in Austin in October 2019. And more recently, he spoke on a new approach to DNS delegations being pursued at the Ietf. David?
Thank you very much. I am actually a little worried. So the first thing I was going to say when I get up here was a very special thank you to Adair and to Val and to Fergus and the program committee, because I completely blew a deadline for getting slides in, and I uploaded my latest set of slides last night, and this is not the title slide. And, okay. So still, thank you. I accept full responsibility. I just missed the deadline that I had not internalized. So I brought up my laptop though, so I can maybe get started, because you don't have to necessarily see the first couple of slides, and we don't want to waste too much time. Oh, thank you. And okay. Oh, yep, it is. Excellent. So one of the things that Corey Quinn mentioned this morning was that as the internet landscape has changed over the past 30 years, a lot of our older skills and knowledge seems to become quite diffused throughout the industry. And so one of the things that I wanted to do was come and start off by letting you know a little bit about what the Ietf is, because I suspect that a lot of you are newer and don't really have a great understanding of how the Ietf fits into the internet ecosystem. It is a standards developing organization, so in this way it's much like the ITU or the IEEE, the mechanical engineers and so on. Notably, it is an international body, but it is completely voluntary. So like some of those other organizations, you need to be an appointed delegate or have some type of industry sponsorship to participate in. The Ietf eschews all that, and it is very much a self-selected body of people who are interested in developing internet technology that can be shared around the network. It is quite old. The actual first meeting of the Ietf was in 1986, at the start of that year, just a few days before the Challenger disaster, if that helps you kind of put things in temporal relevance. And the main goal was really to make sure that all of the protocols that were being developed on the internet were interoperable and able to talk to each other across many different types of devices. And so its core principles include that it is an open, consensus-driven process, that the standards that it produces are freely available, not behind paywalls or other types of subscriptions, that the protocols that are described are able to be implemented without proprietary restrictions on them, that security is now very formally a part of analyzing any new protocol. And since the revelation that the many major organizations were kind of spying on all internet traffic, it is also a core principle of the Ietf that any new protocols are developed with privacy directly in mind. Notably, the Ietf doesn't really have any certification or enforcement powers. Like if you wanted to build a building, right, you would need to have an inspector come and certify that all the standards appropriate to building that building are appropriate, and then you could get your certificate of occupancy. None of that exists with the Ietf. You can put any old garbage you want on the internet still, and nobody's going to stop you. And that has some pros and some cons to it. Notably, Corey also mentioned this morning that IPv6 has been coming any day now for 20 years. I am not quite as dismal on IPv6 as he was, but I will say that it kind of demonstrates the problem, right? Like the Ietf standards still need to be accepted in the marketplace to be successful. And so here's our situation with no enforcement. I bet probably every one of you in the room has already seen this XKCD comic, because there's always an XKCD comic for everything. But this is essentially one of the problems that exists in the standards marketplace and in traffic that's on the internet, is that oftentimes there are multiple competing solutions for one idea, and then the IETF tries to harmonize that. It has been successful in some cases, and it's just one more in other cases. I will also apologize that normally I try to put a bit of humor into my talks. This is the last deliberately humorous thing that is going to appear, and we're going to transition into a much more IETF-like experience where you just get lists of information on slides. Terribly boring, I apologize. I'll still try to make it a little bit interesting and relevant. But again, I'm here because there is surprisingly little overlap between our communities, especially in the North American region, less so in Europe. But like there's Lee and Randy and Job and Warren and a half a dozen other people that I could name that are very active in both the operators community and in the standards community. But when you look at the overall size of the Nanon community, that's under 10%, single-digit number percent of people that are actively involved in both. And they tend to be more focused, understandably, on the routing and operation side. So we get a lot of charges of ivory towerism that are not really unwarranted, that sometimes the standards community will develop something that seems to make a lot of sense, is going to solve some kind of problem, and enterprise operators weren't considered. And enterprise operators look at that and say, wow, you just made it a whole lot harder for me to manage my network. An example of that is because of the IETF's renewed focus on privacy, protocols are now deliberately designed to hide a lot more information, which makes an enterprise operator's job much more difficult in being able to understand the traffic on their network. So I'm here because I wanted to do this increased outreach to the operator community for two different reasons. One is identifying issues like that early on in the process so that standards can at least acknowledge and hopefully work to better solutions for them. And then the other is this kind of outreach also helps grease the acceptance of new standards in the marketplace, because we run into situations, and again, a lot of this applies to the enterprise environment, where new protocols have developed for information sharing, reporting, and so on, that operators are not even aware now exist and can ask for in their own environments. So a quick background on how the IETF is laid out. There are 7 different areas which are very broad areas of conceptual internet technologies. The applications in real-time area covers things that before there was an app store, applications on the internet were along the lines of the protocols that were actually layered above TCP and UDP. For example, the NNTP protocol for Usenet, email protocols, and so on. Those are all the applications of the internet. The general area is kind of the meta group of the IETF, and works on identifying the specific processes and tools that are used by the IETF itself. The internet area is where a lot of the core technologies above routing exist. Things like the DNS, NTP, DHCP, those all live at defining the fundamental protocols that make the internet all work together. And then the ops area is focused on operations, configuration management, and so on. Routing is where a lot of the nanoggers hang out because it's BGP and RPKI and so on. The security area focuses much more firmly on the nuts and bolts of security-based protocols, including PKI, the different algorithms that are involved, how TLS works, and so on. And then finally, the Web and Internet Transport Group works on the protocols that are very specific to World Wide Web applications like HTTP and QUIC. And then within each of those 7 parent groups are individual working groups that focus a lot more specifically on this particular technology. For example, just the DNS registry registrar protocol is handled by a working group that is among several others in that area. The boundaries can be a little fuzzy. Most notably, one of the things I'm talking about here today is that a lot of DNS protocol work, which would seem to fit into INT, is actually in ops now because of the historic working group that has lived there. And then the Internet Engineering Steering Group, The IESG kind of stands as the leadership body that covers the working groups. Each area has a pair or sometimes 3 directors that are responsible for all the working groups in that area. And together they make a board that does final reviews on all new documents that are being published. And then the Internet Architecture Board is the very top level leadership board. And they have their own documents that they provide, but basically they're looking at what direction to steer the entire organization in. The output of the IETF, things start as internet drafts, and that draft is usually identified as to what type of document it's going to be. The most common type is a standards track document. It's something that's proposing a new protocol and a new way of interacting between implementations on the internet. And they have 2 different phases. In practice, those phases tend not to matter a whole lot. But essentially, when a new protocol is proposed, it does need some time to bake out on the internet before it can be moved up to actually being recognized as a full internet standard. And then we have BCP documents, which attempt to describe what experience has told us are the best operational practices for protocols that we're running. Informational documents can describe either protocols that were developed someplace else, or many times they will be a non-protocol document that, say, describes some principle by which the IETF is trying to adhere. And then finally, there are historic protocols. Sometimes these were actually once full internet standards, but the passage of time overcome by events have made them obsolete. And so we keep the document and say, but you really shouldn't be using this anymore. Then there are several different document streams in the IETF. The IETF stream is the main one that RFCs get published in. I'm skipping over a lot of details here because mostly they will be too incredibly boring for you. But mostly what you'd be concerned about is the IETF stream and the RFCs that are produced there, because that's what actually defines the protocols. The IAB stream, as I mentioned before about the IAB, it usually is kind of talking about the overall principles and architecture that the IETF is moving in. There is another branch of the IETF called the IRTF, and they focus on researching how things are actually going out on the network. And then there's the independent submission stream. And so basically everything else that falls outside of what would be normal working group type actions. That includes your April 1st RFCs, it includes John's eulogy, some non-IETF protocol descriptions that it is appropriate to get into an RFC and publish through the stream. But you will never find a standards track or BCP document in the independent submission stream because those have to be working group work. So I'm here to focus on the DNS working groups. As you've seen other talks here today and upcoming, they will cover a lot more of the routing stuff. But the 5 core, or there are currently 4 core DNS working groups, and one that is about to become a new working group. DNSOP is where most of the activity happens. It is by far the most active group, and so that's where most of the protocol work happens. DPRIV was focused on the privacy enhancements that kind of, again, came out of the, the shocking revelation that a whole lot of people were spying on clear text traffic. DNSSD is the service discovery protocol that is usually used inside the enterprise or local network. ADD is for DNS applications that are based around the resolvers, particularly with regard to the new encrypted transport technology that resolvers can use that clients can talk to the resolvers. And then finally, DELEG is a new proposed working group that we hope to have meeting in July. And I'll get to that later. So for the next few slides, this is a very common IETF experience for you all. And again, I apologize, didn't have all the pretty graphs from Aaron and so on. Mostly we have lists of bullet points, say what our outstanding issues are, or what just happened, or what's about to happen. One of the things that if you want to get involved in the IETF that can be a little difficult is you don't usually get any of those background slides. People just, all of the work is supposed to happen on mailing lists. That's one of the things I wanted to point out actually about the volunteer aspect of it too. There is no cost to participate in the IETF. If you want to make a IETF, if you want to make a difference in the standards process, You just have to subscribe to a mailing list and start contributing. There is no vetting process. There is no fee to pay. The people that make a difference are the people that just have time to contribute to whatever's going on. And so all of the work happens in the IETF. The only cost that might be associated with it is going to a conference. You don't have to go to a conference. Everything, there are discussions like these will still happen, but then ultimately everything goes back online and gets resolved on the list as far as where the consensus is for moving forward. So in these dry lists of slides, we're going to find some that have these RFCs highlighted. They're actually, if you go online on the presentation, they're direct links to the RFCs. In the next couple of slides, you'll see some that don't have RFC numbers. Those are internet drafts. They're essentially the documents that are in process in the working group to eventually become an RFC after the consensus process has run its course. So a lot of these, I tried to focus on ones that were going to be particularly interested to operators, and generally that means ones that are interesting to local and enterprise operators, because as I have been told many times by you backbone folks, is you just want to get bits across the network. You kind of don't care what's running under them. And so most of these documents have to do with how you would be able to manage things inside the enterprise. But one thing that might manage the backbone operators as well is a historic problem of the DNS was that complete DNS resolution failure. And this is not when you look up a name and you get NX domain back, but this is basically you tried to contact servers and they're giving you errors or they're not even responding at all. Resolvers have traditionally been extremely aggressive in retrying that type of query, and it can lead to large query storms. And so what we're trying to do now with this RFC 9520 is make sure that in the face of completely unusable answers or lack of answers, that query storms don't flare up and make things worse. As you may remember, back in 2016, Dyn essentially had this outage that was severely exacerbated by the fact that resolvers were aggressively retrying their queries. So we finally got a handle on that and have a lot of recommendations about how to cache that type of failure to tamp down those query storms. Another new set of RR types is the service binding record type, which is trying to address the problem with C names at the apex. Those of you who are familiar with the DNS protocol know that a C name cannot exist with other record types at a particular name. And did this cut out on me again? Okay, sometimes I'm getting feedback and sometimes I'm not, and that's why I've been a little stuttery sometimes. This has been a big problem, for example, for CDNs and other service providers who want to have a name that is stuck to your example.com top-level name. Oftentimes, the service has not been able to be provided there because of this restriction of C names at the apex of a zone. 9460 identifies a new record type that allows the additional specification of where you can find the operator of a particular service. And one of the other things it is doing is helping kind of close up some of the security and privacy gaps in initiating TLS connections. There's another thing that could be useful for those of you that are running DNS services. Right now, those of you who are familiar with setting up a primary and secondary DNS service is that if the primary, say you have a secondary service that you just want to mirror all of your zones, but if you add a new zone, you generally have to do some kind of out-of-band configuration of the secondary to set it up. DNS catalog zones provide a way essentially to say, hey, I'm the primary and I'm going to publish to my secondaries a list of all the zones I want them to carry, and so that auto configuration can happen naturally. Multi-signer DNSSEC is an RFC that actually came out several years ago, but is now finally starting to see implementation. One of the problems with DNSSEC has been key management across multiple providers, and multi-signer DNSSEC sets up the mechanisms that allow this to happen much more cleanly, and we are starting to see implementation that enterprises will be taking advantage of. For example, Salesforce will be using multi-signer DNSSEC for its environment instead of having to continue to maintain a hidden primary system that would then push out the DNSSEC updates to its providers. Extended DNS errors is an extension to the DNS wire format. The question The answer that comes back can now be labeled with some additional information about why that particular answer shows what it does. For example, if you got back a no data answer, that might mean actually that there was data available, but it couldn't be validated. So a DNSSEC failure could be indicated by obsolete key material or so on. Notably, one of the ways it can be used is one of the things that's happening in the DNS industry is that a lot of providers are now, for various reasons, often government action, having to provide blocking to access to some types of sites. But of course, those of you who run enterprises also use filtering and blocking for sites that you don't want people inside the company to be able to access. And this extended errors is able to provide an answer that says explicitly what's going on as far as why the DNS answer came back the way it did. Then DNS error reporting is a mechanism that can be used also within your organization. You host a zone, you have your DNSSEC signed zone. Unfortunately, you might not know until complaints start rolling in from impacted users that DNSSEC has been failing for some reason. And so DNS error reporting tries to improve that situation by providing better monitoring of what's going on around the resolution of your zone. It is not limited to DNSSEC, but that is a good use case for it. So some of our current drafts here, the structured error data for filtered DNS is specifically that government action, your firewall filter lists, cause you want to be able to return some additional information as a JSON blob that describes exactly why. For example, in the extended error reporting, it just says that it was filtered, but it doesn't say because it was a gambling site and you're not allowed to access gambling sites. And now this allows you to specifically tag additional information into what was happening in a machine parsable way that can be used in user interfaces. The DNSSEC bootstrapping is trying to address one of the big problems that DNSSEC has in that there is no formal role for an operator in ICANN's model of registry, registrar, and registrant. And so if somebody wants your operator that wants to provide DNSSEC services for customers, you have to get your customer involved in a process that they might not have the expertise to be in, they don't want to bother, they're just not responsive. But you're trying to provide this service and you still have to go through your customer in order to get the information into their registrar so that the registry will publish it. This allows that to happen in a smoother way that basically minimizes the amount of effort that is needed from registrants who are not actually the operators of their zones. You have probably seen domain control validation in the DNS. Typically, these are long text records that you put in the apex of your domain very commonly for example, to enable Let's Encrypt certificate matching, or to have Atlassian running at your organization, or to Office 365. There are a whole bunch of different services that all use, let's put this magic cryptographic string into your text record and perhaps leave it there indefinitely to continually revalidate that you own this domain. It's making some giant text record sets. This is a way to at least start cataloging the ways that different systems are using it and to come up with recommendations about how to maybe rein in that particular beast and come up with a better way of doing domain control validation. Also, IP fragmentation avoidance is all about how now many, even with eDNS, which is an extension in the DNS packet that allows requests and answers that are bigger than 512 bytes, now many of these answers, like these giant text records at apexes, are exceeding even what a UDP response size can be before it fragments, particularly even over local Ethernet with a 1500 MTU. And so many of you are familiar with the hazards and the security hazards that are presented and other operational issues from IP fragmentation. And so this is a specific set of recommendations for how to make sure that you're not fragmenting your IP packets in order to have better efficient network operations. And then finally, a generalized DNS notification protocol leverages work that has been around, for 40 years, since the dawn of the DNS, of how a server can notify other servers or clients that it has fresh zone data available. Usually it's done by sending them a notification for the SOA record, the start of authority of a zone. This documents how to use the same technique to notify other changes and is particularly beneficial to being able to tell your parent registry that, oh, I have new DNSSEC signing data to publish and I'd like you to go ahead and incorporate that. The Deprive Working Group for DNS privacy has a number of recent RFCs that are pretty relevant to operations. Perhaps one of the more notable ones is that now zone transfers can happen over TLS. Those of you who are running secondary DNS service, many people have global zone transfers turned off, but your zone transfers, even when secured with a technology like SIG0 that validates the data, doesn't provide any confidentiality of the data. So the zone contents could still be observed in flight. Well, now zone transfers can work directly with the DNS protocol over TLS. And similarly, a DNS has been specified now for QUIC. So like DNS over TLS, this provides confidentiality for DNS traffic, but it has the quick efficiencies. I will note just a quick side note about QUIC. QUIC was one of those protocols that was originally developed by Google, but they brought it to the IETF. The IETF adopted it to make it an official internet standard, and in the process did a lot of additional development to improve that protocol, and that demonstrates when the IETF is working really well, that's the outcome you get, is that people can start externally with a great idea, and then it comes to the IETF and the engineering helps improve it. It doesn't always happen that way. And one of the other issues, though, with these new encrypted DNS protocols, DNS over HTTP, TLS, QUIC, they, unfortunately right now, clients don't know how to find these servers. So a lot of work has been done in order to establish where can I actually use these connections. And RFC 9539 describes the probing mechanisms to identify that, oh, I could actually be talking encrypted DNS to authority servers. And then finally, another security and privacy issue is that a DNS over TLS has a couple of rough spots around an otherwise very useful technology, zero round trip time session resumption, but unfortunately the gaps in that make it susceptible to replay attacks, and so this suggests mitigations for that. DNSSD is, as I mentioned, a service discovery protocol that is used inside the network. And one of the things that it has also updated to do, it is very useful in like stateless auto configuration. And so DNS push notifications are something that allows a client to say, oh, I'm going to be particularly interested anytime you update this service record, for example, and please notify me when that happens. There's also a new EDNS option to negotiate leases on DNS updates. Many of you that, again, run your DHCP servers will note that you will have a client that's out there and it joins the network and it publishes a dynamic update and it has this great shiny host name on your network, and then it goes away because it's a mobile device, and yet that name and data binding sits around for a long time and can sometimes be problematic because it's not telling a true state of the network. And so leases basically allow, say for a client, you're going to have to check in if you need some more of this information. The service registration protocol for DNS-based service discovery simulates a lot of this setup. Its initial use case is for making printer setup easier, but it is for other services that are in the network. Again, a very local thing. The Matter standard that relates to the configuration of Internet of Things devices is also planning on making use of this. And then finally, DNSSD had a need for thread environments, which are these low-power mesh networks, to where packets are at a premium. They wanted to be able to ask for multiple records at a time, so a proposal was revived for how you can do this in the DNS, because until now, the structure of a DNS packet effectively caused a pretty tight binding between only being able to ask one question at a time, because the status of the result could be confusing otherwise. And this is my last actual slide as I run down on time here or there. I see you waiting in the wings. It's my next to last, so I'll go real fast. So ADD, like I said, is working on the issues of how do we make effective use of encrypted DNS transports. And so a lot of this has been based around the service binding that can identify when a DNS over TLS or over quick server is available. And then inside your network, being able to have your router advertisement set up advertise that, oh, we would like you to be able to talk to this DNS over quick server as your resolver. And so a lot of this information now that is being provided, we're trying to get more information to a client about what's actually available in the DNS network. And that's what most of this work has to do. And notably, a lot of you probably run split DNS environments where your view of example.com inside your firewall is very different from what it looks like on the outside. And so we're also trying to address the situation about how you can let a client know that, oh, if you want information and you're inside the firewall, you really have to talk to this other server to get it. And then finally, my aspirational talk at the last NANOG was about how we were going to update the delegation protocol between, right now you just have an NS record that gives you the name of a host, and all you can pretty much count on is that that server is going to be running a UDP name server on port 53, and that's where you continue for more information. And so it's made it really difficult to identify a lot of these other things, like when are encrypted DNS transports available, that I can just start talking to them. In the real world, the way the IETF works, we have to go back to square one, even though we, the authors of that draft, had a problem statement in mind, and in fact, in our draft. It still has to, even the problem statement and requirements around solving the problem have to go through the IETF process of consensus. And so that slows things down a little, but like Quick, ultimately, I believe it's going to result in a better final product. And one of the other big things we want to do with that is to have zone owners be able to specify that somebody else is running their DNS, and you can just talk to that DNS operator to find out all the DNS information you need to go. So we expect that it has not been formally approved, but it is on the next IHG telechat in just 10 days from now. It is expected to be approved by then. We're going to have that draft out on the problem statement and requirements by the end of the month, and our first meeting should be in Vancouver in July, and I have 1 minute for questions. Mr. Korav.
So question on, I would introduce myself, but you clearly already know me. Question on 9460. How is the SVB record, how is that different from the SRV records that everyone should be using but doesn't?
Right. The discovery is a big portion of that. And it actually, one of the interesting things about, Adam asked about SRV records, which have existed for a long time and are in fact used by some people. I'm a Minecrafter. Minecraft uses SRV records. It's kind of crazy, but I'm like, hey, look at that. Essentially, the service binding record is extensible and allows more information to be provided. The way a service record was very structured in identifying the protocol and port and everything that it was running on, and then essentially just provided the final target for where you go for that. A service binding record is an extensible key value data set that has some well-defined, still structured information, but allows for a wider range of things to be represented than SRV did.
Cool. Thanks, Tail.
Yep. Online?
Nope.
Excellent.
Thank you.
Thank you.